Hello, Super Kids. It's time for quantitative reasoning. I welcome you all to another exciting moment of creative thinking. You know, when you think, you make yourself more responsible. And today we are thinking about the movements of a clock. Under exercise 12. And let's look at two examples under this exercise. In example 1, we look at the movement of a clock. If a number is given, as 9 plus 2, it means that you look at the face of the clock before you, and then start from the space between 9 and 10 and count and look for the second number 2 times. If you count from the interval between 9 and 10 2 times, the number you will see there is 11, because you are counting to the right hand side of the clock, since the plus sign is taken as or indicates the movement of the clock to the right hand side. Now, if you use the same method for the second number there, for this second number involving 11 plus 4, I think the result will be very easy to come by. What you do is that you write down 11 plus 4, and then go to the face of the clock and start from the interval between 11 and 12. Between 11 and 12. And look for the second number 4 times. And if you have 11, 12, you have on the face of the clock 1. You have also on the face of the clock 2. And if you count, if you begin counting from the interval between 11 and 12, 4 times to the right, 1, 2, 3, 4 times to the right, the next number you see there is 3. So that means 11 plus 4. Based on the movement of the clock to the right hand side is 3. And again, we have some other number here. And this time around is involving the negative sign. That means if you are given 7 minus 6, it means you're going to start from the interval between You are going to start from the interval between 7 and 6 and look for the second number 6 times to the left. You count 6 times to the left. In that case, you have 7, 6, 5, 4, 3, 2, still on the face of the clock here, you have 1. Let's begin our counting. Let's begin our counting from the interval between 7 and 6. If you count, one, 2, 3, 4, 5, 6. So the number you see after counting, looking for the second number 6 times, is 1. So that's why the answer is 1 for this particular number. Then let's look at the last one. The last one involves 2 minus 3 is equal to 11. This simply means that you're going to start looking for 3 from the interval between 2 and 1. Start from the interval between 2 and 1 and look for the second number 3 times to the left. 3 times to the left. That means you begin your counting from 2, 1, 12, 11 on the face of the clock. So you start from 2 and count. Remember, if it is minus sign indicates the movement of this clock to the left hand side. So you are beginning from the space between 2 and 1 and then count 3 times to the left hand side of the clock, and that will give you 1, 2, 3. The next number there is 11. So 11 is the answer. That's how to get 11. You count from the right to the left if it's involving minus. But if it is involving positive sign, you have to move to the right side, to the right hand side of the clock. So that is the method you're going to use to answer any question involving a clock that may be given to you anytime, any day. From this point, we are moving on to the second example. In this second example, we have a magic box here. To me, I don't think there is any magic in this box. All I can see, I don't know what is your take on that. All I can see is a simple design for addition and subtraction of numbers. There is something very unique. This box has a unique property in the sense that all the lines in the rows, columns, and the diagonals have the same value when added up. When all the numbers in each line are added up, they will give you the same the same sum. The total numbers of each the total numbers on each line are the same. And if you look at the row here, this row, if you add it, this very row here, we are talking about this row. If you add all these numbers here, you have 15 to give you 15. If you add the second number, the second row, it's still going to give you 15. Add the third row, it's still going to give you 15. And in this box, we are told that the row is equal to the column. So in that case, if a row is 15, that means the column would also be 15 as it were. Let's look at the column 1. Let's add 1 plus 10 plus 4 to give you 15. If you add the second column in 8 plus 5 plus 2, the answer will still give you 15. If you add the third column, it's still going to give you 15. Let's see whether the diagonal here, this line drawn here, is called the diagonal. If you check very well, adding all the numbers on that line, you're still going to have 15. So that is why I said before now that this box is not actually a magic box. Rather, it has a unique property in the sense that all the lines have the same sum of numbers. So we can claim that based on what is before us right now, we can claim that the row represented by R is the same thing, is equal to the column, and it's also equal to the diagonal. So this implies that if row is 15, then the sum of numbers in a column will also be 15. Then the sum of numbers in the diagonal will also give you 15. We can see that this is a special box with a unique property. And if you are to look for any missing number in this box, if there are numbers missing in this box, here is a step you're going to take. You look at the box that is given to you and then pick a line containing 3 numbers. Add up the 3 numbers. Add up the 3 numbers to determine the sum of each line in the box. That means if a line containing 3 numbers or more is 15, that means you will subtract the sum of any given 2 numbers from the 15 to look for the missing numbers. For instance, let's pick all the numbers in the first row. The first row contains 1, and we have 8 also, and we also have 6 there. Since we have added all of them together, and it's giving us 15, it therefore implies that the sum of each line in the box will give you 15. So if one number is missing, if for instance 1 is missing in the box, let's look for 1. If 1 is missing in this box, let's go to the box again. You can see 1 is here. If this 1 here is not given in the box, if this very one is not given in this box, this is what you do. You've already known the sum of numbers in each line. Remember, I have told you, if you check and there are numbers missing in the box, what you do is that you pick a line containing 3 numbers, add them up to know the total, and that total will be the same for all the lines in the box. So let's look for 1. If 1 is not given in this box, what do you do? Add up the given 2 numbers in 6 and 8. If you add up, that will give you 14. And if you subtract 14 from 15, you are likely to get 1. So let's look for 8 in the same box. To look for 8, you will apply the same method. Since the total of each line is 15, remember, it's not in all cases that the sum will give you 15. There are cases where the sum of each line is 9. The sum can be 10, can be 20. But in this very box right in front of us, right before us, the sum of numbers in each line is equal to 15. So if you are looking for 8, what you do is that you add 1 to 6, and that will give you 7. And if you take away the sum of 1 and 6, which is 7 from 15, you are likely going to have 8. That's how to get 8. Now let's look for 6, if at all it was not given. Please pay attention very well. Assuming 6 was not given in this box, you will look at the box and then pick a line with 3 numbers, add the 3 numbers up to know the sum. Once you know the sum, like we have done here, the sum of each line in this box is 15. Then we use this sum for all the lines. In that case, you add 8 to 1 on the same row, and that will give you 9. And if you subtract 9 from 15, you are likely to have, you're going to have 6. Now, that is not the only direction for looking for a missing number in this box. There are other methods, other lines which you can use. That's not the only line. Yes, we can also use the diagonal here. To look for the missing, you can look for your missing number on the diagonal line. So on this diagonal line, as you can see here, if 5 is not given, remember the sum of the numbers in this diagonal is 15. If you add up 3 of them, you have 15. Remember this line connecting the two angles outside the length and breadth is called the diagonal. And if some numbers are missing, you add the remaining 2 numbers and then take away their sum from 15. Let me show you what I mean by that. You have 4 missing, it's not given. Since you've known the sum already, you write down the sum, which is 15. Add you add 5 to 6, and that will give you 11. And if you do your subtraction very well from the total, which is 15, remember the sum of each line is 15, and that will give you 4. You're going to have 4. Let's use the same method to look for 5. If 5 is not in this box, as it were, what you do is that you will add 4 to 6, and that will give you 10. Take away the sum of 4 and 6 from 15. That is likely going to give you 5. We can still use the same method, of course, to look for the 10th number on that same row, on that same line. I beg your pardon. That line is actually called diagonal. If 6 is not in that diagonal, the rule is very simple. Just go straight to the point and add the given 2 numbers, which are 4 and 5. Subtract your sum. Pay attention very well. The sum is 9. Then take away 9 from 15. If that is done, then your answer is likely to give you 6. These are the methods you can adopt or apply to look for the missing number, or missing numbers rather. Remember, I've told you there is nothing magic in this box. I don't know what's your take on that. There's no magic in this box. So I would like you to make use of the box. Look at it very well before you begin to look for your missing numbers. You must check it very well. I think with all this explanation, I believe we have come to the end of our class for today. I will encourage you to spend quality time to watch the video, attempt your quiz, and take it easy with your creative thinking. Bye for now.